This is going to be a quick video about the area of parallelograms and triangles, things that I'm sure you already know, but it doesn't hurt to look at it maybe a different way. So here I have a rectangle, and the base of this rectangle has 4 squares. So to quickly count the area, we can count how many layers of 4 squares there are, how many rows of 4 squares. So there's 4, here's another 4, another 4, another 4, another 4. So 4 by 5. So we know this has 20 squares. So I want to talk about this technique called shearing. And what that means is we're going to take the top base here and we're going to just kind of slide it over. So we're going to move it over, I don't know, let's say 3 units. So here's point A. We're going to move it to the right by 3 squares, and so this will be my A prime. And if this was B, I'm going to move this to the right by 3 units and have a B prime. So what's going to happen to the area of the parallelogram now that it is no longer a rectangle? Connect, connect, connect. And what we see is that the area doesn't change. The area stays the same. So the height of this parallelogram is the same as the height of the rectangle. The base of this parallelogram is the same as the base of the rectangle. And for a parallelogram, base times height still gives you area. So how far can I push this? Well, I can move it as far as I want. I can move it all the way to here. And as long as it's 4 across, that same length, the area will still stay the same. It's just going to be really, really stretched out. So what's important when looking for an area of a parallelogram? It's important to identify where the base is and where the height is. It's important to remember that a base and height always have to be perpendicular to each other to go from one dimension to another dimension. They have to be perpendicular. So it doesn't matter what this parallelogram looks like or how stretched out it is. What matters is what is the distance between the 2 bases. What is the distance between this base on the bottom and the base on the top? And that distance is always going to be perpendicular to the base. So that same 5, that same 20. All right, now let's look at triangles. So what happens if I turn this into a triangle? Let's see. Same idea. I will have 4 across, and let's say I have 5 up, and I have a right triangle. But now what happens if I take this point and I translate it to anywhere, really? Doesn't matter, I can go right, left, like let's say I move it to here. Does the area change at all? Or I could move it to right over here. Still no change in area. So what is that area for a triangle? Well, if we look at that original one, the right one, the easiest one in which we can tell what that area would be, it is the base times the height. And again, they have to be perpendicular. Really, really important that the base and height are perpendicular to each other. But that would give you all the squares in this array, in this rectangle, and you don't want all of those, you only want half. So 1/2 times base times height. All right, that's it. Thanks for watching, and stay tuned for videos about all the other shapes.